7.2. How about this? Before starting this, let's review 7.1. Is this exponential growth or decay function?
That's a growth.
That's a growth. Why is that? Because the base is greater than 1. 1.5 is going to cause it to grow. So if your base is greater than 1, it's going to be a growth function. If it's a value less than 1, between 0 and 1, it's going to be a decay function. Of course, we also have other things. That's just one of them. We also have to determine whether it's growth or decay in terms of visuals. So let's say I had an asymptote at 1, 2, 3, 4, 5. Here's my horizontal asymptote, y equals 5. Now let's say I had an exponential equation that does this from left to right. What do you guys think? Is that a growth or a decay function?
No, decay.
Decay. Why decay? Because from left to right, it's decaying towards the asymptote y equals 5. So the distance from the asymptote to the graph, look at that. That's a pretty big distance. If you're going from left to right, it's smaller distance, smaller distance, smaller distance till it gets super small. It looks like it's on the asymptote, but it never actually touches, just infinitely approaches. So this is definitely a decay function. You know what? I might as well jot this down, the actual form of an exponential growth or decay function. Okay, so we said that this is a decay function. What does that mean about b? If this is a decay function, what could you tell me about b? It's less than 1, right? Greater than 0, less than 1. What about the a value? Is there anything you could tell me about the a value that has this graph? Could anybody tell me about the a value of this graph? Anything about the a value? It's negative. Absolutely negative. You see, a regular exponential decay function starts up here and goes down here. But instead of up here to down here, it got reflected, and then it got shifted 5 units up, right? Anyways, there's going to be different questions about 7.1. Here's another one. What is the domain of this visual graph? What's the domain? Yep, x equals all real numbers, the domain. How about the range? Y is less than 5, right? You can't say less than or equal to, it's just less than 5 because this entire blue graph is below the y value of 5, okay? So that's great that we're able to do it visually. Let's do one more thing here. What if I just gave you the equation y equals negative 2x minus 1 plus 3? What would the range of this guy be? You don't have the graph. I mean, yeah, one option is to type it into a Desmos, but
Why is less than 3? Because it's going away from the asymptote, and it's a negative.
yeah, that's right. If you think about the transformations, it is a growth function. It got reflected over the x-axis. So instead of growing like that, it's going to be growing down, right? Growing in a negative direction. And the asymptote is a shift of 3 up. So the entire graph has to be below 3, the k value 3. So y is less than 3. Okay, so these are all things that we need to know for 7.1 on the quiz. Let's move on to today's section, solving exponential equations and inequalities. And I do have some notes, but I want to just start with the easiest type of equation. Let's say I had 2 to the x power equals 2 to the third power, and I tell you to solve it. Logically, what does x have to equal? 3, right? I mean, why is that? Because 2 to what number will give you 2 to 3? Well, it has to be 3. It can't be 2, can't be 4, can't be negative or a fraction or a decimal. It has to be 3. So when you have the same exact base, you could technically just forget about the bases the x comes down, the equals comes down, and the 3 comes down, and you're done. X is 3. Do we understand that? Okay. So the key is to have the same base. If you had a 2 right here and a 3 over here, you wouldn't be able to just scratch them out and that would not come down. All right. Let's take a look at the homework, which is on Google Classroom. Now, the one that we just did had the base 2 on both sides, and that's why we were able to eliminate the 2's and the exponents come down. All right, so what we want to do here is have the same base. So I could change this to a 2, and I could change this to a 2, but of course you'd have to have 2 to a certain power to give you 4, and 2 to a certain power to give you 64. So let's do that. Even though there's an easier way of doing it, I'm going to start with the base 2. So 4 is really a 2 squared, and I hope you guys are copying this down. And you still have the power of x plus 35 up there. And you still have an equal sign. And this 64, we want it to change to be the same base 2. So you have 2 to the what power gives you 64. So 2 to the what is 64. Well, we're going to need calculators on this section, guys. So, I mean, we could do it by hand here. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So I counted with my hands. I figured out that 2 to the 6th is 64. Now, if you're thinking, why the heck are you changing the 4 to a 2 squared and changing the 64 to 2 to the 6th? Because now I have the same base 2, which I could eliminate. But let's not forget about the powers that the 64 originally had. It had an x minus 3, the binomial right there. And then we do need to remember rules of exponents, that a power to a power, you need to multiply. So what we're going to do is take this power of 2 and multiply it by the x plus 35, the binomial. So 2 times x is 2x, 2 times 35 is 70, and it's still the power of base 2. So you have an equal sign, and over here, same deal, 6 times x is 6x, 6 times negative 3 is negative 18, and you still have that as a power of base 2. And now that we have the same base 2 and base 2, now we could eliminate these bases, just like we did before, and the exponents come down and create a new simple equation. And now it's just algebra 1 stuff. Solve the equation. Let's get x by itself on one side. I'm going to subtract 2x. Subtract 2x. I'll end up with 4x minus 18 equals 70. And then I am going to add 18. I don't have any space, so I'm going to rewrite my answer over here, or my equation over here. 70 plus 18, that's 88. Equals 4x, and we're going to divide by 4, giving us our answer x equals 22. X equals 22. So let's recap what I just did. Step 1 was to change the bases to be the same base. Make the bases the same. So there's step 1. Make the bases the same. Okay? So after we change the bases to be the same base 2, then we eliminate the bases and write our new equation. So step 2, let's say that. Eliminate the bases and write your new equation. So there's step 2, eliminate bases and write new equation or inequality. And obviously step 3 is to solve. Okay, so again, step 1, you want to make both the bases to be the same base, in this case 2. Step 2, eliminate those bases after you multiply your powers. Eliminate bases, create your new equation, and solve. Now, I did not have to change these to base 2. Let me show you an alternate route. Like there's many roads to the same place. I could have, if I wanted to, recognize that This is base 4, and this could be changed to become 4, right? I could actually change 64, and you could verify this with a calculator, 4 to the third power. That would be the same thing as 64. And then you'd have the x minus 3 right here, the equal sign, and you would not have to change that 4. It would still be x plus 35. And then it would be slightly easier because you could distribute the 3. You don't have to distribute over here. Then the 4's cancel out. The exponents come down. You have your new equation. You'll get your same answer anyway. Okay? But the reason why I went with 2 is because that was the first one that we started with. We changed, or we had the same base 2. Anyhow, let's move on to another question here on this worksheet. So do you guys want to see another one on 1 through 6, or should we jump through to inequality, which is done the same way? Inequality, so that's down here, the second half of the worksheet. Go ahead and pick one, 13, 14, 15, 16, 17, or 18. 17 it is. All right, so yeah, that's a good one. Now, guys, I don't know what base we're going to change these to, but the only number I'm kind of comfortable with is 36 because I know that that's really what to what power? 6, right? So I'm hoping that I could change this to become 6 to a certain power and this to a certain 6 to a certain power. You want the bases to be the same. Step 1, change your bases to be the same. So you guys just said that 36, that's really a 6 squared, but even still, the base is a fraction, and I don't want the base to be a fraction. I want the base to be the number 6, right? So what am I going to do? I'm going to take this 6 squared and I'm going to move it up. And that when I move it up, the exponent sign will change. I will have, inside these parentheses, I will have 6 to the negative 2 power. I think everybody agrees that 6 to the negative 2 power is 1 over 36, right? Okay. So we moved it up, it became 6 to the negative 2. It still has the power of x plus 8. We still have the inequality less than or equal to. Now the question is, could I change this 216 to become 6 to a certain power? And if we can't, then we're kind of stuck, right? But with the calculator, go ahead and try 6 to the third power. 6 times 6 is 36. 36 times 6, I do believe it's 216, right? So 6 to the third power is the same thing as 216. So we have officially changed both bases to become the same base, 6. And we still have the power up here of x minus 3. And of course, a power to a power, we multiply. And we have a single number times a binomial. So you're going to distribute negative 2 times x is negative 2x. Negative 2 times 8 is negative 16, and that's still the power of base 6. Now the inequality is going to come straight down, less than or equal to. We still have the base 6, but up here on the exponent, we're going to go 3 times x, that's 3x as an exponent. 3 times negative 3, that's negative 9 as an exponent. So what we really have here is 6 to this power is less than or equal to 6 to that power. And we said that once we have these same bases, we could eliminate the bases and the exponents come down and become a new equation, or in this case, inequality. So I'm going to have negative 2x minus 16 is less than or equal to 3x minus 9. And that's back to algebra 1. We could solve this thing. All we have to do is get the x's to one side, subtract 3x, subtract 3x. We will have negative 5x minus 16 is less than or equal to negative 9. Add 16, add 16. You will have negative 5x is less than or equal to, what is that, 7? Final step, divide by negative 5, divide by negative 5, and we should remember that when you divide by a negative on an inequality, the inequality needs to flip. So you have x is greater than or equal to the fraction 7 over 5. I want to put the negative in the front instead of keeping it on the 5. That's my answer to this inequality. So again, same exact 3 steps as the previous question. First step 1 is to change both of your bases, bless you, to become the same base, in this case 6. So that's a skill right there, being able to look at numbers, getting your calculator and figuring out what base you're going to change them both to become, right? And then after that, once you have the same base and once you distribute your power to a power, eliminate the bases, you have your new inequality, and you solve it and you get your answer. What do you think? Is that enough examples for you guys to work on these, or should we do one more? Okay, we're good. Now, there's still a second part to this lesson. And the second part, we got to do it now because it's so fun. It's this middle part, okay? Write an exponential function for the graph that passes through the given points. Dang. Think about this, guys. They give you two coordinates, and they want you to write an exponential function. They don't even tell you if it's a growth or a decay function. But we need to write a growth or a decay function based off of 2 points. So in math, you always think about what they want out of you, right? What are they asking for? They're asking for an exponential growth function or an exponential decay function. And what does that look like? It looks like this: y equals a times b to the power of x minus h plus the big constant k at the very end. Now, they're not saying write an exponential function with this h shift and that k shift, or with the asymptote this. They just tell you write any equation you want, right? That's an exponential function. So I'm going to choose to ignore h and k. That way it'll be a little easier. We don't have to deal with any h or k shift or any asymptote, right? And all I have to do is come up with the a value and b value with these coordinates. How the heck do I do that? Well, in any situation in math, when they give you information, take that information and plug it in and see what it gives you. So they give us two coordinates. A coordinate is really an x value and a y value. So that 0, I'm going to put it right here where this x is at. This 5, I'm going to put it right here where the y is at. So I have a 5, I have an equal, I have an a, I have the base b to the power of x, which is to the power of 0 when I plug in that 0 for x. And that's a beautiful thing. Why? Because what is b to the 0 power? 1. Anything to the 0 power is 1. So you can just scratch it out, because a times 1 is exactly 1a, or just a. So you have a equals 5. A equals 5. Guess what? You have half of what you need to write an exponential equation. The a is 5. What do you think I'm going to do with this a value of 5? Plug it in. So I'm going to plug it back in right here where the a is at. That 5 is going to go right in here. Might as well draw an arrow like that. The a is going to go right in here. And let me rewrite my whole thing. So I still have the y, I still have the equals, but my a is now a 5. And the b, I'm still going to have it as b, and the x is still an x. Okay, so how did I find a? I plugged in my first coordinate. How am I going to find b? Plug in the next coordinate. That's right. The next coordinate is also an x and a y value. So the y value, 3,125, I'm going to put it right there where the y is at, 3,125. I have my equal sign. I have the a value 5 that we just found out. I am about to find out what this b is. And the x value of 4, I'm going to put it up here where the x is at. So now it's a question of solving for b. Told you it's fun, right? How do I get rid of anything? You do the inverse operation, you do the opposite, right? So what is the opposite of multiplying by 5 right there? Dividing by 5, dividing by 5. Again, I said the calculator is your friend. 3,125 divided by 5, I believe that is what, 625? So we have 625 equals b to the 4th. How do I get rid of the power of 4? Okay, if I had a power of 2, you'd do a square root to get rid of the power of 2. But the power of 4, you're going to use a fourth root. A fourth root. So you're going to put the square root symbol, but make sure you put a little 4 in that gap. So that's a fourth root and a fourth root. Whatever you do to one side, do to the other. Now, your b value is equal to, and technically, whenever you apply a square root or a fourth root in an equation, you should put a plus or minus in front of your answer, but we're not going to do that. I'll tell you why in a couple of seconds. But what is the fourth root of 625? 5. If you're like, how do you figure this out? If your calculator doesn't do it, you could just start using your calculator and say, okay, what number times itself 4 times gives me 625? So if you try 4 times 4 times 4 times 4, it's not going to be 625. 5 times 5 times 5 times 5, it will be 625. So b equals 5. And now we have the information to write an exponential function. Y equals, the a value is 5, parenthesis, the b value is also 5, to the power of x. This is our answer. The reason why I said we're not going to put a plus or minus in front of it is because a negative 5 would actually mess up this equation. A negative 5, and the reason for that, think about this. If I plug in a 1 with a negative 5 right here, I'm going to get a negative answer. But if I plug in a 2 with a negative 5 squared is a positive 25. So the outputs are going to be jumping from negatives to positives, from negatives to positives, and that's not going to produce exponential growth function. It's going to be all over the place, all right? So this is why we just put we ignore the plus or minus and just put the positive 5 right in there. I hope that makes sense. What do you guys think of that? Some of you look depressed. You guys want to do 8, 9, or 10? 9. Guys, look, I'm serious. This is not difficult, right? You guys just look at it and you get all discouraged because you see decimals and fractions. It's not difficult at all. Okay? Look, they want us to write an exponential equation. Here it is. Y equals a times the b to the power of x minus h. But the minus h and the plus k, we're not even going to write it. So what should I do first? Plug in x and y. The x is 0, the y is 3/4. So my y is 3/4, the x is 0. And we know that b to the 0, that's 1. So we have our answer already. 3/4 equals a equals 3/4. A equals 3/4. What now? Plug it in, right? Plug in the a value. So we will have y equals 3/4 times b to the power of x. Now what do we do? Plug what in? The second coordinate. X is 2. So you're going to put a 2 right there where the x is at. The y is 36.5. You're going to put that 36.5 where the y is at. Let me do that. 36.5. Actually 0.75. My bad. 0.75 equals 3/4 times b to the x power, which in this case is 2. And let's solve this thing. Any ideas? Divide by what? Okay, divide by 3/4. I know that's kind of weird, but you could do this on a calculator, especially because we have decimals. 36.75 divided by 3/4. What do we get? 49. That works out nicely. So we have 49 equals b squared. How do I get rid of the square? Square root. Square root. 7 equals b. Technically, it should be a plus or minus 7, but again, we're not going to put the plus or minus. It's just going to be positive 7. And again, the reason for that is we want an exponential growth function in this case. Y equals, the a value is 3/4. The growth factor, the b, is 7, and it's to the power of x. Okay? And again, we don't put the negative 7 because the negative would cause it to mess up when we think about the graph. So this is the answer. Once again, on the quiz, on the practice quiz tomorrow, or on the actual quiz Friday, I'm going to actually ask you to type in a equals whatever you get, comma, b equals whatever you get. Okay? Easy peasy. I don't know, should we try another one, or is that it? Your master's at? Okay, how about this? What base am I going to change those to?
The usual.
16? Now, that would be great if 16 squared was 64, but I know that's not going to work. 4, right? 4. Right? You got 16 right here, you got 64. You could change both of them to become base 4. So I'm not going to do the whole thing. I just want to show you how we're changing the base. This 16, we're going to write it as 4 squared. And this 64, we're going to rewrite that 64 as 4 to the what? 4 to the... Use a calculator if you need to. Third. 4 times 4 is 16 times 4 is 64. Now, of course, I don't want a fraction as a base. I want the 4 to be the base. So I'm going to move this up, and it's going to be what inside the parentheses? 4 to the negative 2 power. Okay, and it's still to the 3x minus 4 power. And you know what? Let me change this guy. I want to write it less than or equal to, I want to rewrite it 4 to the 3rd to the x minus 1 power. So now that we've changed it to become the same base, we're supposed to distribute and distribute. Now, if you want to skip this next step, normally I would write this as the exponent of 4, write this answer as the exponent of 4, and then delete the 4's. But once you do this a couple of times and get comfortable with this, you could just skip that step of deleting 4's and just already start 2 times 3x, or negative 2 times 3x is negative 6x. Negative 2 times negative 4 is positive 8. Bring down the inequality. 3 times x is 3x. 3 times negative 1 is negative 3. And jump right into the inequality that you're going to solve. Does that make sense? In other words, instead of rewriting everything over the base 4, I just right here eliminated them and then distributed and wrote my new inequality, and you continue solving from there. All right, guys, so I need you guys to practice. We have a lot of practice on this worksheet. All the solutions are on Google Classroom. The worksheet's on Google Classroom. So let's do it.